Hello everyone. Sequential logic circuits. Sequential logic circuits have some form of memory built in. Uh, so sequential logic circuits are generally termed as two-state or bistable device which can have their output or outputs set in one of two basic states, a logical level high or logical level 0. Uh, as standard logic gates are the building blocks of combinational circuits, bistable latches and flip-flop are the basic building blocks of sequential logic circuits. Sequential logic circuits can be constructed to produce either simple edge-triggered flip-flops or more complex sequential circuits. So this is the structure of sequential circuit. This input and this is output, and this is the memory. This memory have feedback. It gives the feedbacks to the logic circuit. uh, there are three types of sequential logic circuit: asynchronous, and synchronous, and pulse driven. Asynchronous circuits that change state immediately when enabled. Synchronous circuits that are synchronized to a specific clock signal. Pulse-driven circuits, which is a combination of the two that respond to triggering pulses. So this is the SR flip-flop. This is a simple example for sequential logic circuit. SR flip-flop, also known as SR latch, can be considered as one of the most basic sequential logic circuit possible. This simple flip-flop is basically a 1-bit memory bistable device that has two inputs. One which this is set set the device and is labeled as this S bar, and one which will reset the device. This is the one uh, is labeled as R. So this is the two outputs, Q and Q bar. This flip-flop is made by using two NAND gates. They are interconnected. So this is the truth table for uh, SR flip-flop or SR latch. These flip-flops have two status: state and reset state. Uh, when the S is set to 1 and R is set to 0, the uh, Q bar is set to 1 and the Q is remaining in the 0. When S is set to 1 and R is set to 1, there is no change in the outputs. The outputs will remain in previous status. So S is set to 0 and R is set to 1, the output will change. Q is changed to the 1 and Q bar is changed to the 0. It means Q bar is reset to the 0. When S is set to 1 and R is set to 1, the result will not be changed. It will be remaining in the previous state. When S is set to 0 and R is set to 0, Q and Q bar both will be set to 1. It is invalid state. So this is the timing diagram for the SR flip-flop. Let's simulate SR flip-flop by using simulation software. So this is the simulation software for we want two NAND gates to construct this SR flip-flop. I will place as this. I'll set the gates as this. I have selected two NAND gates, and we want two inputs. Is an R, and we want two output. I set two LEDs as the output. So then we have to connect this, set this input as S, and I'll set this as R, reset. And I set output as Q, and another output as Q bar. So then we have to connect these together. And this input be come from the output of the second NAND gate. All are set. Then we'll check the status. So when S is set to 1 and R is set to 0, the output must be Q as 0 and Q bar as 1. Now Q bar is set to the 1, so I'll change R input as 1. You see, the output is not changed, it's remaining in its previous status. So then we'll set S as 0 and R as 1. So the output has changed, Q as 1 and Q bar as 0. So then we'll change both as 1. So the output is not changing. Then we'll set S and R as 0. The both Q and Q bar set as 1. This is the invalid status. This can be this in this situation we cannot define any output. So I'm going to create a timing diagram for this scenario. So I change S R Q, so S R Q and Q bar. So this is the timing diagram. So now I'm going to change R as 1. So you can see that the R is changed to 1, but the Q and Q bar is remaining in its previous status. So now I'm going to set S as 0. Now you can see the Q and Q bar values are changed. So now I'm going to set both S and R as 0, 1. So the Q and Q bar will not change. Then in the both S and R are 0, the Q and Q bar shows 1 in the timing diagram. So this is how to construct sequential logic circuit using simulation tools and timing diagram. So I'm going to stop this from here. Thank you.